Hello everyone, I hope you all are doing great. Today we will be learning about full wave rectification, FWR. Full wave rectification is just like half wave rectification that we have studied in our previous lecture, but the only change in the difference between full wave and half wave is that in half wave rectification we used only one diode. In this case, full wave rectification, we will use two types of diode. In the first case, the positive side would be first and then the negative side. That means PN junction would be something like P and then N. And second diode would be first N and then P, the side. Or you could say that first there will be a cathode and then an anode. So that's the only difference between full wave and a half wave rectification. Because of these two variation in the diodes, we get a continuous DC current like this because of two diodes. But in the case of half wave rectification, we all know that our wave diagram was something like this. The negative version was A plane, and this creates a pulsating wave sort of thing. So these two differences are the major differences between full wave and half wave. Let's start our full wave rectification, and first let's create a full wave rectifier. How to do that? First of all, these two are the sources from where we'll get the current, or we could just make it like this. So this is the source of our current. Then we'll be having first diode, in which this is the P junction. We all know what is the P junction and what is the N junction. P is actually a type of semiconductor which have holes within it, and N type of the junction, or what we could say N type of the side, has some sort of negative electrons within it. In the case, the holes work as a positive side, positive anode, and this N type semiconductor work as in negative cathode. So we could actually write it as this is the positive side and this is the negative side. Then in the second diode, we do have first N junction and then the P side, P type semiconductor. So in this case, the negative side comes before and then the positive side. This is the construction. Then again, we all know that in the half wave rectification as well, both of the diodes will be connected with a resistor load, which is actually used to calculate the current, which is again a type on a really different discussion why it is used as a load and why do we use it to measure the current. This is a different discussion that we're going to do in our upcoming videos. Well, then again, this whole system ends up at ground. This is a type of end of the current. At the ground, all type of currents will become 0 volt. Either we are providing 100 volts or either we are providing only 0.1 volt. After coming at the side of the ground, it will become 0. This is the property of ground, by the way. Okay, so this is our half full wave rectifier. Let's consider this one, or let me just change my pen's color so we could actually monitor the changes in the process. So in this case, let's consider this one as D1 and this one as D2, diode number 1 and diode number 2. And we all know that in the AC current, we do have a positive node and then a negative node. The polarity changes itself node by node. So let's first consider positive node and then the negative node. For full wave rectification, first let's consider the positive node of the AC current. Let's say that we are providing 10 volts. So the magnitude of the volts for both of the diodes will remain same. Like if we are providing positive 10 volts, so positive 10 volts will go to the PN junction and positive 10 volts will reach out the NP junction. The volt will remain same. We all know that if we are talking about the PN junction, so this side of the PN junction would always have 0 volt. And I'll tell you very soon that why we are considering zero volt. For now, just keep this in mind that here we are having 0 volts and then here we do have the 0 volts. For the results, let's first make a table. Positive cycle. Well, it is also known as half cycle rectification if the examiner changes the terminology, so you must be known about these things. Let's first consider what will happen in the D1 if we'll provide the positive cycle of the AC. So for the consideration, let me change my pen's color and reduces its weight. Okay, positive cycle. First of all, we all know that the positive cycle is actually facing the positive side of the wave as well. So first point, we are facing the positive cycle, and we all know that positive repel each other. Second thing, now on the number line, just consider that we do have the 0 volts and then the positive 10 volt. Now tell me which one is greater, 0 or 10? Well, we all know that positive 10 is greater than 0. So in this case as well, the negative side of the PN junction cannot attract 10 volts since it is less than the 0 volt. So both of the conditions actually satisfies the condition of the reverse biasing, or we could say here the process is reverse biasing. So in the case of D1, it blocks the AC. Block AC. Now let's consider the D2, the diode number 2. So let's consider the positive volt. Now first case, the negative side of the PN junction is there. The positive 10 would be attracted to the negative 10 because we all know that negative attracts the positive version. Either we are having positive 0 volt, but this won't be considered since we are having the positive and negative attraction here. So in this case, the negative electrons will attract the positive electrons or positive 10 volts, and it will enter up by attraction, and it will push the, because what is the current? Current is flow of electrons. So in the case of negative diode, the positive 10 volts will get attracted towards the negative electrons, and they will actually push the electrons. They will actually help the electrons to move forward to the holes, and this will cause the flow of current. So in the case of D2, the current is actually allowed, the AC is allowed to be flown. So this was the basic condition. Now let's consider the negative cycle of the AC/DC. Now in this case, in the second case, let me first remove this one so we could have some space to actually do it again. Well, everything will remain same, but only the polarity of the wave will change. Okay. Okay, so we are done with it. Almost done, almost done. Okay, so here I have just removed the SIM so we could have some space. Well, in this case, in now, what will happen? Now we'll provide the negative 10 volts, the negative node of the current. So in the first case, when we'll see this D1, now what happened in last D2? Because of the change, because of the opposite charge, the negative positive thing got attracted. Same will happen here because of this negative and this positive side, the current will start flowing. And in this case, the negative and negative will repel each other and there won't be any flow of current. So in the case of negative cycle, the D1 actually conducted the allowed the current to flow, allowed, and D2 will block. Same process will be repeated again and again, like for the D3 D4, not for the D3 D4, like again the negative cycle will come and D2 will allow and D1 will block, and then again a cycle would be started. What if we draw it graphically? So let's draw it graphically. In the positive node, what happened? Just a minute. Okay. In the positive node, what happened? First, D2 allowed, D1 blocked. We won't consider D1, we'll only consider D2. In the second negative cycle, D1 allowed, D2 blocked. In the third cycle, again, because of the positive cycle, D2 will allow and D1 will block. In the second condition, D2 will allow, D1 will allow, D2 will block. So this will continue and sort of pulsating DC. And that's the major difference in the half cycle and the full cycle as well. The diagram of the half cycle is something like this. Because it doesn't have two sort of diodes, so it only creates one single pulsating wave. However, here we do have some sort of two pulsating waves. Same condition is applied for another type of rectifier. Well, it's not included in our course, so we don't study it in detail, but it is called bridge rectifier. Bridge rectifier actually is an application of this full wave rectifier. Let me showcase you its figure. It actually looks like something this, and again we do have this. Okay, so this is the diagram of bridge rectifier. It works like this. This is a rough tough diagram of bridge rectifier, which is actually the combination of high potential and low potential, and both of the diodes, four diodes, are actually attached as a bridge. And bridge rectifier is mostly used to maintain the frequency of the wave. That's the only function of bridge rectifier. Well, I hope this video lecture was helpful for you. If yes, then please subscribe our channel, and thank you so much for watching.